Hello everyone, my name is Fadhlil from the University of Melbourne, Australia. Today I would like to present my research titled The Influence of Boreal Summer Madden-Julian Oscillation on Precipitation Extremes in Indonesia. This research is in collaboration with Sandro, Lubis, and Sonni Setiawan from Rice University and Department of Geophysics and Meteorology, IPB, Indonesia. So the introduction, what is MJO? MJO is basically an eastward propagating cloud clusters in the equator with a period of 30 to 60 days. It has two phases, the active phase in which the convection is vigorous over the MJO, and also the suppressed phase in which the convection is suppressed. So the impact of the MJO is reducing the probability of extreme rainfall, also modulating the total precipitable water in the tropics. There's so many impacts of the MJO, and these two are what are the most important in this study. So these are the previous research about the influence of MJO on extreme rainfall in Indonesia by Muhammad 2020. So as you can see here, the left-hand side is during the Boreal winter MJO. The increase is around 60 to 100% over the active phase of the MJO. If you can see in the right-hand side, we see that the active phase, the green, blue colors, shaded blue-green in the Boreal winter MJO, the active phase over the maritime continent, over the Indonesia, is around 2, 3, and 4, and also 5 for the eastern part of Indonesia. So that means an increase of around 60 to 100% during the phase 2 to 4 during the Boreal winter MJO. But the MJO has two different propagation during Boreal winter and also the Boreal summer. In the winter, as we can see here, the propagation is more southward propagation of the MJO, while in the Boreal summer, you can see that the propagation is more likely to the north, like here, and that means the impact should be different between the Boreal winter MJO and Boreal summer MJO. So the purpose of this study is to look at the regional impact of the precipitation during the Boreal summer MJO and also the dynamics behind the impact. So the threshold is 95th percentile during the extended Boreal summer, May to September. Over the 4 is divided region, west, north, east, and south. And the impact of MJO and extreme rainfall, we can see here that in the west of Indonesia, the extreme rainfall is 50 to 80% more likely during phase 2 and 3, while in the north of Indonesia, it's 40 to 70% more likely during phase 2, 3, and 4. And in the east, there's also 20 to 35% more likely during phase 3 and 4, and in south, the effect is not really that great. It's only 11% during phase 2. But the decrease of probability of extreme rainfall over Indonesia is majorly the same. It's about 20 to 60% or 75% during phase 4 to 8, mainly for phase 5 to 8. So the impact of MJO on extreme rainfall, we see here that in the map here, so the shaded region is the change of extreme rainfall probability. So 20% increase means 20% more likely to happen. And the circle is indicating the location of the stations that we use two different data sets, the Aphrodite and also the stations. So the circle is indicating the location of the stations, and the field circle is indicating that the result passed the confidence level test with 95% confidence level. So what we look here, that we can conclude that during phase 2 and 3 over Sumatra and Borneo, the rainfall is more likely to happen by 60 to 50, 150%. Over Sulawesi, the increase is around 100% and 60% during phase 3 and 4. And over Papua, the increase is up to 60% during phase 4. And also the decrease of probability of extreme rainfall is mostly the same during phase 5 to 8. The majority is experiencing the decrease in extreme rainfall probability by up to 75%. So what was the dynamics behind the extreme rainfall? What causing it? So first we see the vertically integrated moisture flux convergence, the shaded region, and also the OLR, the contour. So the green means convergence, brown means divergence, and blue lines means negative OLR or convection, and red lines means positive OLR or suppressed convection. So what we can take from these figures is that moisture convergence plus negative OLR means that increase of extreme rainfall likelihood. So increase of the likelihood of extreme rainfall. And vice versa, the moisture divergence with positive OLR means that the likelihood, decrease of the likelihood of extreme rainfall. So yeah, well, we can see here that the phase 2, 3, and 4, maybe 4 over the eastern part of Indonesia, there is an increase in moisture convergence and also negative OLR, which means convection. And what we have here is the vertical moisture advection, in which the vertical moisture advection, the upward motion is indicated by blue and the downward motion indicated by yellow. So upward moisture advection is equal increase of extreme rainfall probability, and downward moisture advection equals the decrease of the likelihood of extreme rainfall. And all of this association is also found during the Boreal winter MJO. So the conclusions are the MJO increases the probability of extreme rainfall events in Indonesia by up to 160, 150, 160% during Boreal summer. Positive increase of precipitation is observed during phase 2, 3. The greatest precipitation impact of the MJO during Boreal summer occurs over Sumatra, Borneo, and Sulawesi Islands. So over the northern part of Indonesia, we experience the Boreal summer MJO, but over the south of Indonesia, like Java, the impact is small. And the decrease of extreme rainfall precipitation probability occurs over most Indonesian region by around 60%. So while the increase is only over the north, but the decrease is affect mostly all of Indonesian region. And the modulation of the frequency of the extreme events is highly associated with anomalous lower level circulation due to MJO. So the enhanced rainfall appears to result from induced upward motion of the large-scale convective system. So the vertical moisture advection, the convergence that causing enhanced rainfall, or vice versa. The downward moisture convergence and also moisture divergence resulted in suppressed rainfall. So that was it. Thank you for listening.